Question 12, Part A. A particle is moving in simple harmonic motion about the origin, with displacement x meters. The displacement is given by x equals 2 times sine of 3t, where t is time in seconds. The motion starts when t equals 0. Part 1. What is the total distance travelled by the particle when it first returns to the origin? The particle is oscillating about the origin such that the maximum displacement of that oscillation is 2 meters on either side of that origin. So for the purpose of visualization, I've sketched the graph of x equals 2 times sine of 3t, where x represents the displacement of the particle at time t. And initially, that is at time t equals 0, the particle is at the origin. Then it's moving to the right of the origin until it gets to point A, which is the maximum displacement of that particle, which is 2 meters away from the origin. Then it's going to move back toward the origin. So this is the first time it reaches the origin after t equals 0. So that means it's moving 2 meters to the right-hand side till it gets to point A. Then it's going to move 2 meters back until it gets to the origin or gets back to the origin again. So 2 meters forwards, 2 meters back, obviously gives us a total of 4 meters. And I've stated that here. So from O to A, the particle travels 2 meters, and then from A to B, the particle travels back 2 meters. So the total distance traveled is 2 plus 2, which gives us 4 meters. Part 2. What is the acceleration of the particle when it is first at rest? The coefficient of the time variable t is 3, so n is equal to 3. We can use that to find the period of motion. So the period is given by capital T is equal to 2 pi over n, where n is equal to 3. So the period is 2 pi over 3. Now if we go back to the graph that was sketched in part 1, the period represents the length of time it takes for one full cycle. So in other words, from the origin to point C, is 2 pi over 3 seconds. Now point B is halfway between the origin and C, so that occurs at time pi over 3 seconds, so that's half of 2 pi over 3. Now point A, which happens to be the point where the particle is first at rest, and this can be observed from the graph, so no calculus is necessary here, and that occurs at a point that is halfway between the origin and point B. So that's half of pi over 3, which is pi over 6 seconds. So let's go back to our solution. And I've stated that here. So the particle reaches point C, which is the origin, at time t equals 2 pi over 3 seconds. Now the particle reaches point B at time t equals pi over 3 seconds. And the particle reaches point A at time t equals pi over 6 seconds. And that's where the particle is first at rest at that time. Now the displacement equation is x equals 2 times sine 3t. To get the velocity equation, we differentiate the displacement equation with respect to time using the chain rule. So the velocity v is equal to 6 cos 3t, differentiating the velocity v with respect to t, again using the chain rule, we get the acceleration a is equal to negative 18 sine 3t. At time t equals pi over 6 seconds, the acceleration a is equal to negative 18 times sine of 3 times pi over 6. Now 3 times pi over 6 is equal to pi over 2. So the acceleration a is equal to negative 18 sine pi over 2, and sine pi over 2 is 1. So the acceleration a is equal to negative 18 times 1, which equals negative 18. Therefore the acceleration a is equal to negative 18 meters per second when the particle is first at rest.